Okay, so today we're just going to continue looking at simplifying radical expressions. Take a few minutes to have a go at these questions, just to warm up. Welcome back. I like it. So yeah, as you said, this one simplifies down to root 2, root 25, which gives us 5 root 2. How about the second one?
You multiply the numerator and denominator by root 2 to get rid of the square root 2.
Okay, with these type of problems, there's a multitude of different ways you can go through the problem. I would probably have divided root 32 by root 2, but the same. So you wanna make it root 64 over 2 by multiplying the numerator and the denominator. I wouldn't necessarily do that. I would join them together and divide 32 by 2. Next.
No, but I mean,
We'll still get to the same place.
root 2
What's the square root of 64?
18.
That's right. I just multiplied.
And this leads us to 4. Yeah, I would explain it like this.
Okay. I know.
But there isn't a correct method, there isn't a correct pathway through as long as you hold the rules of math accurately. Okay, so what are we going to get on this one if we simplify this one? Well, we'll start off by rewriting it in radical form like this. Then what do we get? Let's add, Chloe.
You can distribute the root 2 to both sections, so then the x, you take out x in power 2, so it's x on the outside, and then you have root x on the inside, and then the other one would be y to the power 2.
Yeah, I would probably write this one like this, for clarity. My pen is reacting slowly, giving me a very square looking thing. Those look good, so my computer's going slow. I would rewrite it like that to reduce any ambiguity. In order to reduce the ambiguity here, I introduced the decimal, the multiplication point. What about the last one? 1. All right, that was an easy one. So we're just reviewing the laws, the exponent laws. We have the product property. Just highlight it there. First up, we have the product property. A to the m times a to the n is we add the exponents. We have the quotient property when they're divided with the same. And notice that the base is always the same. So if the base is the same in both, we subtract the exponents. If we have them raised up to powers, we then just multiply the exponents. And then we have just showing how they distribute here and how they distribute here.
So, I have a question. On the very last one, if n is a negative number, we just switch places immediately.
You could. You could. So what George is saying on this one is something on the lines of a over b to the minus m is equal to b over a to the n is equal to b to the m over a to the m. Something's not going well with my computer this morning. Okay.
What was it?
Simplify the expression, assume the variables are positive, exponents simplify as much as possible. I think you guys can have a go at these ones. Take 2 or 3, 2 minutes. Why don't we do them together? All right, how should I start this first one? You
Add the powers. So, yeah.
We'll add the fractions. So we have the same base, add the fractions, it's going to give us 25 to the 10 over 5, 2, which is 25 to the 2, which which is
625.
625. 5 to the power 4. Our second one, what should we do here? Subtract them and we get 8 to the 1 minus 2 over 3. 8 to the 1 over 3. Sorry, negative 1 over 3.
1 over cube root 8.
1 over.
1
1
over
over
2.
1 over 2 is 1 over cube root 8.
Oh, okay. You're telling me the next line.
Yeah.
You're not correcting me. I'm like, I was trying to hear you guys all speaking, and I was like, are they correcting me? Did I get it wrong? But no, you're wanting to move to here. Like this?
No.
Wouldn't
1 divided by
be
cube
just
root
the
8. I
eight?
don't think it matters.
Or like this?
1 over 2.
Yeah, yeah. Like that.
No, it is for both. It's for the one. It doesn't matter. Can it be plus minus a half?
No.
No, silly rubbish. Alright. Are we good on that one?
Yes, sir.
Let's try the next one. Have a go for yourselves again, and then we can do it together.
I'm going to put it minus y. Good. 4 over 3 minus 2 over 3 is 2 over 3. 2 over 3 times 2 over 2 is 4.
No, because you multiply 16 by 2 and by 3 over 2 as well.
Oh, what if it's at the top separate?
Or we just take the, no, we just take the 4. I said.
Good job. Okay, I got y.
Yeah, over 64. Oh, or we can just do y over 64. That's 49.
I did that. So I did 4 times 3, 2 times. Okay, why did I not change this already? This one's 3 over 2, not 2 over 3. I'm trying to look at Yeah, 12 over 6 and 1. Because it's 6 over 6. So I take y squared and and then I cross out one of the y's. Yeah. So I said y over 6. Yeah, that's the same thing as when we do it. Like 4 over 3 minus 2 over 3 is 2 over 2, 2 over 3 times 3 over 2. Yeah. Well, I only think is the bases are specific. Okay, it's the next one. Yeah.
I genuinely always understood them.
We got I'm sorry.
Are we ready?
Okay. Oh, okay. You just you find the cube root first and then you do the square. So cube root would be 3 and then 3 squared, whichever one. You can do either way. But he said but it's easier if you go down than go up. He said always like it's better to always go this way because it's shorter. Wait for it. Which one goes to?
Oh, we just did. There we go.
What does round down?
not 612. Huh? Is it? Why is it not 612? It's 612. Why is it in a cube? It's 1 over 2. Tomorrow.
I think we should look at
What is the
well, it's not. It's like an hour to end. It's just like
yeah, it's 80 over. What's the cube of 80 over? Maybe we have to do like 27 to the power of 2. No, what's the cube of 80 over?
That's all. 8 to the power of x is same as log base 8.
81 now. Well, like an alpha it's on the
All right, that. Okay. So I just want to start this first one off myself.
So 3 squared equal to 9.
I think I would take it like this. I think that's a good start. I think that's a good start.
Are we going to do it?
And then I'm going to go here. Sorry, I'm just doing 4 cubed. So 64.
Which is just y over 64.
Either way it's fine. Either way it's fine. I started writing the 1 over before I realized it was going down to 1.
We didn't do y part, right?
They're the same.
We didn't know how much the 16 by 2. So how do I do this? So it has to be square root.
Shall we look at the next one?
Yes.
Let's have a look at the next one.
Like this?
Should we do the same again?
Yeah.
So I'll do it in a couple of steps, but this one's the cube root of that square, so it's 9. And then the other one is going to be x to the 3 over 4 times 2 over 3. That's 9. What's this one going to be? We're going to have 6 over 12, which is
Root x.
6. You can't square root x because you don't know what it is. You can just simplify. Alright, have another go for this one. Try to remember to pause this time. Okay, this one's quite easy. I'll show an extra step. I wouldn't normally do this, I can just pull out the terms in my head. But what I would be doing would be this. So I can just pull out all things to the power of 3 from it. And that's going to give us 2xy cubed x squared.
he pulled out the 2 and the y.
Which steps? Look, this is the cube root, this is the cube root.
Yeah. Oh, yeah, what's that? Okay.
Pull it out back to it.
Wait, so can I write that down?
I can send it here. Look. This root. Just because it's in a fractional exponent doesn't make it any different. Okay, let's have a look at our next bit of to know. We have here the product property and the quotient property. And as we saw with these ones when we were working last class with negative numbers, that you assume this is true if A and B are positive. Notice this little bit here. That's why we were getting into difficulties last time when you were using this rule on negative numbers. Take care. So this is true when they're positive, and I just used that one, didn't I? Let's have a look, see here. All right, let's have a go at that one.
So if A and B are negative, we can't use that.
Yeah. No, it's worse than that. Sometimes worse. Okay, let me just show you what I mean about these being positive and we should take care. If we take the we try square root minus 4 times square root minus 9. We'll go wrong if we apply this root because they're both negative. That would give us minus 4 times minus 9, which would give us 36, which gives us 6. The correct way of doing this
There's a bigger one there. Divide it by you can
is
just
to
divide by
simplify this to
So you can divide by
2i
times
times 3i, which is 6i squared,
Well, 8 times
which
2.
is minus 6.
If you had, like square root of negative 9.
So what is 4 x
You can still
squared?
go, you can still separate square root of
No, I'm
negative
doing a
9
different
by
question.
Yeah, you can pull up the
So
square
third
root.
root of
You
4
should pull up the square root once.
and third root
Collect
of
them
6.
together.
And then
Because then one of the numbers is positive.
so it would be 4 x
Oh,
squared.
yeah.
4 xy squared times the third root of 4. I think we just
Well, that's basically what I'm doing
Yeah, I
here.
don't need a
So I'm pulling it out
I just don't know if you can do this. I feel like you can't. If you can, what did I do? Because there's a y.
I would pick it up either way.
I'm going this way.
Like, what if I, like, because you know how, like, sometimes you write for, like, cube root of 256 times cube root of y. Yeah, so I think we can.
That's weird.
Yeah, negative 6. You just use integration? Because that,
Generally don't use it when A and B are negative. Don't use this rule when A and B are negative. You can use it if A is negative or B is negative. So don't use the rule when both of them are negative, which is the issue that is made here in the red one. Whereas here in this pathway, the blue one, I separate the numbers into a positive and a negative part, so I can pull them apart, and then I don't have the issue. So only, both of them can't be negative, one of them. All right, let's have a look at this problem. Ooh, so we got lots of cube roots. What's the cube root of 256?
There is no.
It's not.
There is one, but it's like 4 point something.
Isn't it? Let's do this then. Isn't it 2 to the 8?
No.
Is it 2 to the 8?
Yeah, it is.
Yeah.
Alright. So then we can pull out 2 to the 6.
What's 2 to 6?
Can't we?
Yeah, and then leave
So-
two square inside.
So if we pull out the 2 to the 6 and then divide it by 3, that will give us 2 squared. 2 squared.
Oh, no,
Or
we
I should
did it
pull
right.
out the ends.
We did it right.
We did it right. We did it right.
We did it right. We did it right. I think.
Yes, no, we did it right. Look, she has x squared. That extra. We did it right.
You did 16, that's good. I was right.
I don't know. But it's y squared on the outside. Because it's y is not 6.
I pulled out 2. Thank you.
Can you do it in the easiest method? But we did it.
So I say I was.
It's a cube root, right?
Just know that 2 to the 8.
Yeah, I don't know. Sir, we did it, but we did it without figuring
There's
out.
always 100 pathways through these problems. There's like a multitude of pathways through them. And as everything's positive, there's so just going back to what we were asked here about the sign, about this being tricky when you've got 2 negatives. That's why in these questions it says assume that the variables are positive, so you don't have to worry. That's why it says assume that the variables are positive, because if they're all negative, it can cause issues. Not the same. Where are we? Our modelling question, special. Have a go at this modelling question. Discussing groups, I think, for this one.
Williams.
So what we need to do for part A is we can start with the left-hand side, which equals cube root 3v over 4 pi, which equals the cube root of 3 over 4 pi times the cube root of v. And in order to do this type of decimal, we have to do it on the calculator. What you should do for a show that of this type is I'll just press Control and press here, get the cube root up here. Control divide by quotient 3 over 4 pi. Then press enter. If it comes up like this, press Control enter to get a decimal. And what you should do on this one is you should take more than the number of decimal places given in the show that, to show that it rounds to that value. So you show that this is approximately equal to, this one is approximately equal to 0.620. I'll look down. I only need one more decimal place than is given, which equals 0.62 cube root v. So I've shown it. To show one extra decimal place, to show that it rounds. When you show one extra decimal place, make sure you round it at that point correctly. Make sure it's rounded at that point correctly. Or you can show a few more decimal places. So I could do 62035 and decide where to cut. Take care when you round and round again, because that will cause problems.
When we have to write 0.621 instead of 0.620.
That's a 3.
But you can write 0.6204, right?
Yeah. But sometimes it's difficult. If you round, you can carry a rounding up and mess things up. Maybe I would stop at the 5. For B, what should the radius for a float needing 4.4? What should the radius? All right. So we're going to try and find the radius when the buoyancy needs to be 4.4. So just simply putting it into our calculator. Cube root, then calculate the factors. 3 times 4.4 over 4.
Wait. Oh.
1.02.
Because this calculator, that's what I'm saying, this calculator doesn't have the with the weird square roots.
Oh, why was that?
Oh, we see that percentage. That's great. Yeah, 'cause it's easy.
Okay. All right, to finish off today, have a go with the IXL activities. Let me stop the video. I clicked the wrong button, I clicked delete.
You actually
No.